Hvala. So, welcome everybody. Thanks for coming out. I can imagine that after 2 days of being listening to talks, you're quite tired. So, I appreciate it really that you came out to my talk as well. So, a few months ago, I came home from work and I needed to decompress a little bit. So, I sat on the couch and I stared at the TV, which was turned off, like you're watching a blank screen right now. I had the same thing. And my wife, she notices that and she asked me, like, what's on your mind? What's troubling you? So I tell her, like, well, yeah, work. I made a solution, but I don't feel like it's the right solution. So my brain is still kind of trying to think of different solutions. And oh, by the way, I'm giving a talk at a conference. She's like, oh, really? That's nice. What's your topic? It's about building a GameBoy emulator. She's like, building a what? Because she doesn't work in IT, so she knows how to operate a computer, but she's not very technical at all. So I tried to explain to her, like, computers, they work based on the sequences of zeros and ones, but those sequences that makes sense to one machine doesn't make sense to another type of machines. So what I'm actually trying to do is build a program which will take the sequence which are meant for one type of machine and transform it to a sequence of zeros and ones which is understandable by a different kind of machine. Like, the Game Boy is one kind of device and my laptop is a different one. So she goes on like, oh, really? I didn't know you could do that. And I was like, yeah, you're right. I actually don't know how to do that because by profession I'm a web developer. I build websites, web applications, mostly backend systems, but I've never done any of these kind of things. I also don't have a bachelor or a degree in any computer science or anything, So she's like, really? So you're going to give a talk on a topic on which you're clearly not an expert on? Is that a smart thing to do? And actually, that's her way of saying, well, if I were you, this is a bad idea. Really don't do it. So I was like, well, yeah, But before I could come up with an answer, our 4-month-old baby woke up, started crying, and my wife went upstairs, and I was left alone, sitting in the room, watching a TV screen which was turned off, feeling overwhelmed, and thinking, like, how the hell am I going to do this? So today, I want to take you on my journey of building a Game Boy emulator with Elixir and Scenic. So after having heard that introduction, you might be thinking, well, how do you come up with that idea? Is it even a good idea? Are you even sane? Why would you do this? So I was looking for a topic for a talk, because like Merlin yesterday introduced, like if you want to improve your communication skills, then it's actually good to do some public speaking. Now I learned it's also good to do writing, to learn to listen. So maybe I should have done one of those two things and listened to my wife. But anyways, I'm here now, so let's go on. So I was looking for a topic for a talk, and I saw somebody build this with Scenic. By the way, I'll move the mouse. It's a little bit distracting. Oh no, it's not my mouse. Oh, nice. Somebody built this demo, which is a Shadow of the Beast. It's a popular game in the, 80s, 90s. And I thought, well, let's use Scenic. And I saw somebody else who wrote the Game Boy emulator using Elm, which you might have seen some slides, some talks also during this conference. And Elm is a functional language, aesthetically typed. It's meant to be run in a browser, so those are all things which make it hard way of building something low level like a Game Boy emulator. So I thought, well, if this person can do it in Elm, then I can do it as well, right? And I also thought when I came up with the idea, like every time I have a good idea, I think, oh, I'll make a startup out of it, I'll make lots of money, etc. And then you go Google for that idea, and then you found 10 other companies which have done that already. So I thought, okay, finally I have a good idea. Nobody else has written this thing in Elixir. Here people even written a Game Boy emulator using Emacs. You can do everything in Emacs, so why not a Game Boy emulator? But nobody ever did that with Elixir, so I thought, okay, I have now a good idea. I'll send in a proposal, and it got accepted. So yeah. So, and also, a friend of mine recommended to do some TDD, in which this case means talk-driven development. You come up with an idea, something that you would like to learn, you submit a proposal, and then when you get accepted, you have to learn it, because you have to give a talk about it, right? It's okay, all those themes combined, I thought, well, let's do this. So today, let's begin our journey. A small disclaimer, like you already heard, I'm not an expert on these things, and because we don't have that much time, I'm going to go over a simplified version. And also, I wrote an emulator so you can play a game with it, but I don't endorse piracy. And Nintendo, if you're listening, I don't want your money. You know, don't want to take your money away from you. Please don't sue me. So, first things first. What is actually a Game Boy? What is an emulator and what is Scenic? So a Game Boy is actually a device from the 80s, the end of the 80s. It was made 30 years ago. Has anyone ever played one of these devices? Raise your hand. Quite a lot of them. Wow, nice. So if you see that it's built 30 years ago, you must be feeling old right now, right? You're welcome. So what is an emulator? So it turns sequences of, you might think that it's something like this, like the Matrix. You turn those zeros and ones around to something else. But in reality, it looks more like this. So this is a version that I used, in which you see the screen that the Game Boy is also showing, and some other parts which you can use for debugging. And what is Elixir? The first time I Googled it, I found all kinds of perfumes. I found even that there are popular guitar strings called Elixir, but it's none of those. It's also not a drink that makes you more vigorous, but it's actually a programming language built for distributed fault-tolerant systems, mostly targeted for telephone systems. But nowadays, the web is actually quite similar to telephoning systems, so it's also used for building web pages or web applications. And what is Scenic? So some of you might think, well, he's going to build a Game Boy emulator with a car. I'm not. So Scenic is a library in Elixir, and we'll go into detail what it is later on. So what does a Game Boy actually consist of? What are the components that are inside of them? So you have a CPU, you have some memory, the memory management unit. You have the pixel processing unit, which is basically what we nowadays call a GPU. You have some I/O, audio, ROM, some data and cartridges and stuff like that, and timers, etc. But we're only going to focus on the CPU, memory part, and the screen, what you can see actually. So the CPU is a 4 megahertz CPU. So it means, in theory, it can process 4 million instructions per second. In reality, all instructions take 4 cycles, so it's close to at most 1 million. And a CPU has registers, so for each instruction is processing, it also needs to remember some stuff. So if I ask you, how much is 1 plus 2 or A plus B, then you have to store those two numbers in your mind and combine them, etc. And that's where those registers are for. So registers in the Game Boy are all 1 byte big, but can be, in some special occasions, combined into a register of 2 bytes. So that's why you have to your right, the registers which are combined and which have 2 bytes. And some registers also have a special meaning. The SP is the stack pointer, PC is the program counter, so it keeps track of where the CPU is in the code. And you have the F registry, which stands for flags. So it's used if for some instructions, if the follow-up instruction needs to know what happened in the previous one, then you can set a flag. For example, if the result of the previous instruction was 0, then the 0 flag will be set. So, small break. So the memory management unit, actually, if you look at a picture, you see that the CPU is actually not the central part and the central component of this device. It was the memory management unit. So whenever the CPU needed for some information from the screen or from the inputs, like the buttons you press, it would actually look at an address in memory and see what happens. And the same way around, if the CPU wanted something to interact, something to happen to the screen, it would write to a specific address in memory, and then the other component can pick it up. So the memory management unit links the CPU to other parts, and it has 65K in total. The pixel processing unit takes a part of that memory, reads it in, and translates that to what we see on screen. So I thought, well, let's open up a file, let's open up a first program that's being run on the Game Boy, which is called the boot ROM. And this is what I actually saw. So some numbers, so some hexadecimal numbers. So it turns out when you compile programs, they're not anymore in English. There are actually a bunch of zeros and ones, a bunch of numbers in sequence. So this is what you then see. So a small example how that would translate. So if I would write a program in some C kind of language which calculates the sum of numbers 1 to 5, then this is kind of the way you do it. You loop over C, and you count them all up into the ACC variable, which is all done. And if you would write something similar in machine code, like in assembly, which is close to machine code, you would write it like this. So you fill the A register with 0, the C register with 5, and then you go into that, well, you're already in loop, but you add the contents of C to A, and you decrement C, and once it hits 0, it will stop jumping to the beginning again. So if it's, in this case, if the flag is not 0 and Z, it means it will jump up back to the beginning. So that's basically how people wrote Game Boy games at that time, really low level. And once you compile that example, it turns out into something like this. So in total, it's 2, 4, 6, 8 bytes, in which the first byte states which instructions it is, and it may be followed up by some arguments. So I started writing those instructions, but the list is quite long. So these are 256 of those instructions in total, but, wrong one. But if you can, not look at the right place. But there's also a nice trick one, which is this instruction, which says prefix. And this is a prefix to another table of another 256 instructions. So for me, this was quite overwhelming. I thought, well, you know, I've submitted a talk I have no idea on. I have to do it in a few months. How do people, how do people do this? How do people test this? So I went on to a Discord channel, which is a kind of a chat channel, and I asked, well, how do people actually test this? I said, oh, don't worry. Writing opcodes is the easy part. Okay. Once you have written some code that can render the state of the Game Boy on screen, there are some specific ROMs, some specific programs to test those instructions. It's like, yeah, really nice, but I've just thought it out, so it will take me a long time. But I said, oh, you don't have to implement the rendering part. You can also implement the serial cable to it. So each Game Boy could be linked up by a cable to one another. But those test ROMs, they also output their results through those cables. So you can also implement that. I was like, that's even harder, It involves even more hardware-specific stuff, which I have clearly no idea on. So, I started writing those instructions, those opcodes, as they're called. So those instructions have a number, and that code corresponds to instruction. And I wrote something like this. So we have a function execute. In this case, it's the load 2BC registry, the next two numbers, next to bytes. So it takes as a first argument the current state of the Game Boy, the opcode, so the instruction number, and then it actually goes over that instruction, doing whatever it needs to do, and then it returns a new state of that Game Boy. So I could actually, well, slowly test it out, and later on I wrote a run function, which would take that Game Boy state, run the next instruction, and then loop recurse, keep on going until it actually was exhausted. So I was like, okay, this is going well. And at a certain moment, I thought, well, okay, it's now kind of time to try to draw something on screen. Which for me was, from one side, it was a pleasure, but it was also a pain to get it right. And the Game Boy, it doesn't have 50 shades of gray, but it has actually 4 shades of green. So I don't know why, but they actually put a green cover, screen gloss in front of the LCD. So that's why you see green shades instead of gray ones, actually. So let's get started. So a Game Boy, when you look at it, the display has some background. So like trees or things you're moving around. The sprites, which are kind of the characters you see move around. And it also has the concept of window. So if you ever play Pokemon or one of the others, you always see a dialogue saying, okay, choose this or that. And those are implemented as windows. And the backgrounds, or basically everything, consists of tiles. So 8 by 8 tiles. And a different part of memory which says, okay, at the first part, we're going to take tile number 5. And the next one will be tile number 20 or whatever. And that way it actually has a mapping from that screen to the tiles that it actually has in another part of the memory. So if you, this is kind of how that looked like. So on the left side, you see what the rendering is. And on the right side, you see the specific 8 by 8 tiles. So once I understood that, I thought, okay, then this is the time to actually try to use Scenic. So what is Scenic? If you look it up, it's a client application library. But in my opinion, it's more like a library which helps you build apps that have an UI. But it has a very specific use case because it's meant to be, well, as I say, it's primarily aimed at fixed screen connected devices. So basically, you can think of them as IoT devices, like your smart thermostat or whatever. Those are the kind of applications that are meant to be built with Scenic, not a GameBoy emulator. So this is how the first example, if you start it up, looks like. So you can have buttons, you can have input items, you can have some primitives, and you only write Elixir code, and you don't have to worry how that is drawn on the screen. So this is a small example in which the author changes some color, some words, etc., and then refreshes, and you see that all happen. So the goals of Scenic were all tied to making an IoT device work. It had to be available, small, fast, etc., etc. And the goals, like the non-goals, were running it in a browser, doing 3D, or using immediate mode. And in graphics, there are two modes of representing something, which is retain mode and immediate mode. And retain mode is basically what we're using as web developers. We write HTML, we write a div or input item, and we don't care, we don't even know how that is rendered onto the screen, like which pixel goes where. Immediate mode is the opposite of it. It's where the developer actually really controls which pixels goes where, which is useful if you're writing a game or a Game Boy emulator. And that's not what Scenic did. So the other kind of building blocks, are very similar to web development. You have scene, graphs, components, primitives, of which the rectangles, I thought, wow, this is interesting. Maybe we can use rectangles to represent the pixels on the Game Boy. So we'll just draw rectangles of 1 by 1, give them ID because you need to change them later on, give them a color, and then put them somewhere where they belong. So there's a different function that actually calculates which pixel goes where because they need to do the mapping. And then this is kind of the final thing you have to do. But because the Game Boy has a 256 by 256 grid, it means you have to do this 60,000 yeah, 65,000 times, which doesn't perform well. I mean, it worked. I could make it work, but it's not I don't know, it's not the best solution. So I looked at the example that I found the first time, like the Shadow of the Beast, how they actually did that. And I found out that he wasn't drawing rectangles by themselves, but he was using images, sprites. So that running animal, person, whatever it is, basically consists of 4 images, like one standing still, one leg in front, other leg in the front. And basically by cycling through those images, you get the animation, you get a feeling that the person or, I don't know, beast is running. And that's not something that I did in my code. So I thought, well, maybe I can kind of duplicate that, right? Because the Game Boy has tiles, so let's use something that's similar to tiles. You write a rectangle of 8 by 8, use the tile that we have to render, and put it somewhere on screen. But Scenic doesn't know, where that image or where those tiles or whatever comes from. So we have to somehow translate those tiles into, pixels or whatever that Scenic can interpret. So I wrote a function that looks like this. I won't bore you with the details, but the thing that I want to kind of zoom into is the part in which we generate a PNG image. So we have to open a file. We state how big it is, etc. We write to it, which I've clearly left out. But you write the data to it, the RGB values. Then you close it. And then you actually have to start the transitioning into Scenic. So you have to create a hash out of it, calculate a hash. And that hash can then be used to represent an image, to give it to Scenic and say, hey, this is a rectangle you have to draw. And this is, by the way, the hash that you use. So that's also not a convenient way to do. So that was about 4 weeks before my talk. You can imagine I was stressed out a little bit. And I thought, well, what are the other options? So I emailed the author of Scenic saying, like, hey, I'm building a GameBoy emulator, and I've tried this, and what are kind of the other options? So he emailed me back like, you can just use some C function, which you'd again use a binary, so just one blob of data, and then every time you want to update it, you give it a color. What else did he say? An XI coordinate, and then you can use just that C part to poke the pixels at the right spot. And it should only take a few lines of C, but I've never written any C. So I had the brilliant idea, why don't I pre-compute everything? Why don't I pre-render all the tiles? Because, I mean, they're just 8 by 8. Wouldn't that be easy? So that's actually a combination of 64 options, and each of those has 4 different options. And I don't know, for the people that are good at math, they'll probably start calculating how much that is. And for me, it took about 2 hours and 5 gigabytes of memory later to find out that it was way too big a number of combinations to actually calculate beforehand. So I thought, maybe that's not the best option. So, no. Wrong slide. So then, luckily, a new version of Scenic came out about 2 weeks before the conference. And the kind of the important part of it is, instead of giving it rectangles or giving it having to compute a hash and all the other things, you can just use a texture. And so it works like a cache. So you predefine, I want to use this texture, and then later on, once you have to compute every frame, do the animation, you just loop over all the pixels you have, and then you say texture put, and put them at the right spot. So I thought, okay, that's a lot more easier to do. So how are we doing on time? Oh, we're right. We have lots of time. So let's do a small demo in between. So with that knowledge, how far can we get? No? Let's see. By the way, if you have any questions in between, please ask them. Nope. Nope. Okay, cool. It's nice, right? So you get the logo first, and then you get a small disclaimer, and then you should get the screen of the title screen, right? But you don't see that. So anybody have an idea why you see those garbage things come around? No, not even you? Okay. He already wrote, or he was working on a GameBoy emulator in Rust. So imagine you know some details. But the thing is, let's go back. So the Game Boy had an LCD screen, but it was still using kind of an old way of rendering stuff. So if people remember those old TVs, so nowadays if you buy a TV, it's kind of large in width and in height, but it's not that deep. So it's only, it's only 2 centimeters thick. But the old screens were actually quite deep, and that's because they used an electron gun to shoot electrons at the screen to show something. And the rendering mechanism in the Game Boys is actually the same. So it draws one line, goes back, draws another line, etc. And the kind of the time in between those switching lines is called the horizontal blank. And once you get at the bottom and have to go way up, it's called the vertical blank. And that was actually kind of the vertical blank was the moment for developers to write something to video memory. Because if you do it in between, while it's rendering, you get garbage output, like I showed you. And the second thing that we'll get at later on, but the thing that we haven't talked about are interrupts. So how does the CPU interact with other parts of the other components? So small question or guess. We have 2 screens, 2 versions. Do you think these are very differently represented in the video memory? Like the Game Boy uses tiles. Do you think the tiles from one screen are different from another? Raise your hand if you think so. Nobody? Oh, wow. You know more than me. So in memory, these 2 pictures, like the streets, the road, this part, is exactly the same. There's no difference. The only difference is kind of a trick they used, is while they're rendering, so after the Game Boy has drawn one line, it has a small moment, H-blank moment, which goes to the next line. And what they did, in that exact moment, they would shift the rendering a few pixels. So for this example, it's kind of a straight road. But for this example, they actually have taken that road, and for the first line, they've moved it all the way to the right. And then slowly, each line for line, let it move back, and then let it move to the right again. Which, if people have limited resources, they get creative, right? So that's what the developers of Game Boy games also did. They got creative because it was a limited device. It never got changed. So all the versions of later Game Boys that came out had to be backwards compatible with the first one. So once that Game Boy was built, that Game Boy was made, it would run through all the other different versions of the Game Boy. Well, it was very creative, I think. And it's nice to hear what kind of tricks people used back in the days. So the next step would then be to expand our run function and to handle the interrupt. And the way that interrupts what they actually are. So, for example, if on the Game Boy device, if you press a button, that button is directly wired to the CPU. So voltage goes up, a certain part of the CPU flag is written down, and Yeah, then at the next cycle, so before it actually triggers the next opcode, it actually looks at the part of the memory, sees, okay, I have an interrupt, I have to do something else, and then it looks at which kind of interrupt, so it can be different components, which interrupt is being raised, and that means it will actually run code in a specific predefined part of the memory. So every cartridge would, for example, for the vertical blank moment, would go to the same address, execute some code. Once it's done, it would continue playing the game. Right? So that's kind of in small how you could write a GameBoy emulator. And every time I got further and further and further, but there are always new edge cases, always new things that you have to add in order to have a fully working GameBoy emulator. And even after you're done, I've been reading those Discord channels, people always find new ways to optimize to make it more precise with the actual Game Boy. So it feels like you're playing Mario and you save the princess, but it turns out, oh, there's another stage, there's another thing, another challenge for you to go around. So to sum up this talk, writing a Game Boy emulator is fun, although very tedious. I mean, if you even miss one bit, if you write one byte wrong, then the whole program goes into a different branch, and it's kind of hard to debug where it comes from, because there's almost, well, there can be a million instructions which are processed per second. So, if your screen is for 1 second going in the wrong direction, yeah, good luck finding it. It's in between one of those million operations. And next, I haven't showed that much code, but I think Elixir and Scenic also is fun, and yeah, you should definitely try it out. But you've come to you come to a conference maybe to learn some new stuff. But I think if you want to learn anything new, you can read a book, you can watch an online a video or whatever. So what is kind of the added value of going to a conference? And that's basically to talk to other people, to mingle. So I want to close this talk with some food for conversation or some talk. So as developers, we often like to say, I like to learn new things, right? I mean, raise your hands. Do you agree? Do you like learning new things? Yeah, that's true, right? But I'm not sure if you're all speaking the truth. Because, I'm not saying that you're lying. Maybe you are unconsciously. But really learning something really new takes a lot of time. It's painful. If you go to some medium and you ask questions, it makes you feel dumb because everybody else, read through the guide, made it the first time, and you didn't. So it makes you feel dumb. But instead, I like to think that we want to be good at new things, right? Today and yesterday, you had some good ideas. You have seen a new framework, and you think, I want to do that as well. And we want to be good at new things without actually having to go through that painful process. And the other thing that I've kind of come to realize, that everything that we do with tech is just code, right? I mean, I used to look up, well, still do, used to look up a lot of people who could make very complicated things, but in the end, it's just code. It's something we can all learn to understand, given we have enough time, enough energy, etc. So nowadays, I respect people who put a lot of effort into something instead of people who like to, write shiny things. So with that being said, I want to thank a few people. Manuel Fuchs, who gave me the idea. My wife for, being forgiving, given me the time to implement all these things. Massimo, who wrote The Shadow of the Beast. Boyd for Scenic. People from Elixir and Erlang. And also a small thank you for all the people whose only responsible is ambitious. So I would go around people telling, like, I'm building a Game Boy emulator. And I expected people to say, oh, cool, can I join? How does it work? And everybody would say, ambitious. And leave the conversation at that. I don't know, maybe they knew more than me, maybe they were wiser, but that was their only response, and they left the conversation at that point. And of course, I want to thank you for listening. to building an oversimplified, quite naive, half-finished version of GameBoy emulator with Elixir and Scenic. If you have feedback, my name is Tonći Galić. You can find me on the internet as Toxified or on Twitter or whatever. You can email me and please leave some feedback if you want. So thank you. Oh, one more thing. I said food for thought. So if you ever want to feel a little bit nostalgic, I brought the Game Boy with me, which I think should work, right? So if you, want to do something else, please find me later on.
Thank you, Tonći, very much. Does anyone have any questions?
Everybody wants to play a game, I guess.
Okay. Well, thank you very much. If you want to... Oh, we have a question? Great.
Hey, thanks a lot for your talk. It's really great to see that you managed to get this up and running. I was wondering, do you have any recommended reading for looking up the Game Boy architecture?
Yeah, that's also a funny thing. Like, when you go into these things, you find all kinds of documentations about how you should do this. But then you find out, oh, this doesn't really make sense. And you find actually that even the oldest documents, even the documentation everybody recommends, contains errors. So I had to go through a lot of trouble to actually compare documentation with another, and one said it worked like this, the other said it worked like that. So yeah, there is an actually the bottom link, I think it stands for Game Boy development, which is a list of all kinds of resources, all kinds of things you can read up on. But be wary, because a lot of those documentations aren't correct. And yeah, like I said, learning new things is very frustrating, especially if the documentation is not right. I mean, as a developer, I'm used to documentation not being right, but if it's something you don't know anything about, it's even more frustrating.
Hi, I have a question. I was wondering if you know anything about the efficiency of your emulator. Like if the Game Boy required 4 megahertz stop rate,
yeah.
How much of, what processing capability of your emulator, or did your emulator need?
You mean like in clock speed wise or those kind of efficiencies, or?
Yeah, like what's the minimum size processor that would be able to run your emulator?
Yeah, it's a good question. I haven't really tested it, but the thing is I've written very naive version, so it's kind of hard to say, oh, this is performant enough or it isn't performant enough. If you well, people have written Game Boy emulators in anything, so it should be possible, right? But in my version, for the memory part, I use just one big blob, one big binary, instead of having different parts for different types of subsystems. So if you, for example, I don't know, would like to make produce a sound, you write to a specific address in memory, but you don't write all the bits, and that's something that I haven't done. So I kind of have to apologize for not having a full answer. I don't know. I'm just curious. No, it's okay. It's also funny to say, but by the way, each Game Boy game, if you look at it, it has a stamp of approval saying original Nintendo seal of quality. So we all like to think that Apple was the first company that came up with the idea of an app store which they had applications which were approved by Apple, but Nintendo actually did that before them. Because when you boot the first program which is run on the Game Boy, it compares the logo that it has on the Game Boy with the logo or which specific addresses on the cartridge to see if they actually have that logo on disk. And if you, as a non-Nintendo company, you ship your product, you ship your game with a logo which is not yours, you have to be approved by Nintendo. So Nintendo was actually the first company that came up with an approval on an app store or whatever you want to call it, before Apple actually did that. More questions?
Anybody else? Okay. Tonći, thank you very much for this very interesting talk.